Today we're going to continue our conversation about current electricity. As a reminder, electricity or electric current is the movement or flow of electric charges, in this case electrons, from one place to another. That electric current flows in an electric circuit, which is a closed path that the electric current follows. A simple circuit consists of minimally 3, but generally 4 parts. The first part you must have is a source of electrical energy, generally a battery. Then you need a load. A load changes the electrical energy into another form of energy, such as heat, light, or sound. For example, a light bulb is a load that converts electrical energy into light and heat. Finally, these parts are connected together with an electrical conductor, such as a wire. It is also useful to have a device such as a control switch to control the electric current, usually a switch. These parts are connected together to form a circuit, which is an unbroken path for the electrons to flow from the negative end of the battery through the light bulb, through the switch to the positive end of the battery. The switch is a control device which allows for open and closed circuits. When the switch is open, no electric current can flow through the circuit because it cannot flow through the air gap because the blade is up. It can also be said that the switch is in the off position because the blade of the switch is up. This is a diagram of a closed circuit. When the switch is closed, the electric current will flow through the circuit from the negative terminal of the source of electrical energies to its positive terminal. The switch is in the on position when the blade of the switch is down and the electrons are flowing through the closed circuit. To review the parts of an electric circuit, there must be a source of electrical energy which converts different forms of energy, for example, chemical, heat, mechanical, magnetic, etc., into electrical energy. Examples include dry cells, batteries, photoelectric cells, and outlets. A circuit also needs an electrical load, which is a device that converts electrical energy into another form of energy, such as light, heat, magnetic, etc. Examples include a motor, which changes electrical energy to kinetic energy and heat, or a stereo, which changes electrical energy to sound and heat. It is also nice to have devices to control the electric current in an electric circuit. It controls the movement or flow of electrons in a circuit. These include a switch, fuse, or circuit breakers. And finally, these parts of an electric circuit are connected together using electrical conductors. Metal wires are used to connect the parts of a circuit since they allow electrons to flow from atom to atom in a controlled path. The wires are usually covered with an insulator to keep electrons in the circuits and prevent shock. The most common metal used for connectors is copper. And now let's draw some circuit diagrams. Circuit diagrams are used instead of pictorial diagrams because of their simplicity. Circuit diagrams use symbols to represent the different parts of the circuit. Please review the symbols for the different circuit parts. Please follow these rules for drawing circuit diagrams. All diagrams must be drawn using a pencil and a ruler. Connecting wires are drawn as straight lines or 90-degree angles when they change direction. Symbols are used to represent all components. Use arrows to indicate the direction of the current from the negative terminal to the positive terminal of the source of electrical energy. This is different from Khan Academy. We will always indicate the direction of the current from the negative terminal to the positive terminal. The electrons will leave the negative terminal, an area of high electrons, to an area of low electrons, the positive terminal. So let's practice drawing a schematic diagram. Here's a simple circuit which consists of a dry cell, a switch, and a light bulb. Press pause and see if you can draw this schematic of this simple circuit. Is this what you drew? Note that this battery has 2 cells in series. Also note that the electrons leave from the short negative end of the battery through the switch to the load, which is a light bulb, back to the battery. Our schematic diagram is in the opposite direction of the electron flow shown here. Here, the electrons leave the negative end of the battery through the light bulb, through the switch, back to the battery in a counterclockwise direction. Here, the electrons are leaving the negative end of the cell through the switch, through the light bulb in a clockwise direction. This is more correct because the switch should be before the load. Now let's talk about connecting circuits. There are two basic ways in which loads and/or cells can be connected. That is, loads can be connected in series and in parallel, and/or cells can be connected in series and in parallel. Loads that are connected in series will have all the electrons in the current flow through each load. A series circuit only has one path for the current. These three light bulbs are connected in series. However, these three cells are also connected in series. That is to say, these three cells are connected in series so that the electrons only have one path for the current to flow. So overall, this whole circuit is in series. All of the loads and all of the cells are in series. Another way that components can be connected together is in parallel. When electrical loads are connected in parallel, the current will have more than one path to follow. All the current will not flow through each load. A parallel circuit has two or more branches for the circuit. Part of the current goes through each path. In this circuit, the cells are still connected in series. However, the loads, the three light bulbs, are connected in parallel. At these three branch points, the current splits here. The current comes back together here at these three branch points, and the electrons return back to the positive end of the battery to complete the circuit. It is an oversimplification to say that this is a parallel circuit, since this circuit has cells which are in series, but it has loads, three light bulbs, which are in parallel. It is better to describe components of a circuit as being in series or in parallel. The tool we use to measure current in an electric circuit is an ammeter. Ammeters are connected in series with loads or sources of electrical energy. An ammeter is used for measuring the current leaving the resistor or entering the battery. Voltmeters are used to measure the voltage. They are connected in parallel with loads or sources of electrical energy. A voltmeter is used to measure the voltage of the resistor, and they are connected in parallel. And that's all for now. Now it's your turn to get to work.